Hi everyone, this is Babaiah, Assistant Professor of EC Department, MLR Hyderabad. Today I am going to explain about the time response of analysis. This is the second unit name in control system. So previous we discussed about the introduction of control system problems, all the block diagram reduction rules, SFG signal flow graph, as well as some of the problems on based on the block diagram reductions, as well as the signal flow graph. We are calculated all these methods by using to determine the transfer function, right? Now we are going to discuss about the time response of analysis. This is in this we are going to learn some what is the meaning of time response, and introduction to time response, what is the time response, and transient response and steady state response. All these we are going to learn today lecture. Right. Coming to the first one is introduction to time response. Just see here, the time response of the system is the output of the closed loop system as a function of time. Here see, the time response of the system is the output of the closed loop system as a function of time. If the any system response is within the function of time is known as the time response. Simply we are going to denote the time response is the C of t, and the time response can be, every time response can be obtained by solving the some differential equations governing the system. Alternatively, the response of this system, any system C of t, can be obtained from the transfer function of the system and the input of the system. Just simply, our for example, I am going to consider the one closed loop transfer function. Here, just our R of S is my input, and here G of S is the gain, and last here C of S is the output, and feedback is with negative feedback is H of S. This is the, or else here I am going to redraw again. Here R of S is my input and G of S is the gain or open loop gain, negative feedback, H of S is the feedback gain, C of S is my output. Here from this circuit we are going to obtain the transfer function, or we are going to calculate by this closed loop transfer function, that is closed loop system. The closed loop transfer function C of S divided by R of S is equals to G of S divided by the open loop gain divided by 1 plus, here negative sign is there, so opposite sign we consider, 1 plus G of S into H of S. This is the transfer function. Simply I am going to this transfer function as M of S. I am going to consider this M of S. This is our closed loop transfer function. When we are going to calculate the time response, now we are going to apply the Laplace transform. Just see here, we are going to apply the inverse Laplace to the transfer function. Just here, the transfer function is here C of S. Previously this one is, from this C of S equals to what? C of S equals to R of S into, and here G of S divided by 1 plus G of S into H of S, right? H of S. So for G of S divided by 1 plus G of S into H of S, I am going to consider as M of S. So that is C of S is equals to, C of S equals to, directly we consider C of S equals to R of S into M of S. Simply, when we are going to calculate the time response, just to simply apply the inverse Laplace transform to the output of the closed loop transfer function, that is C of S. See here, the output or response in S domain, C of S is nothing but the S domain output. Now we are going to calculate the time response to just simply apply the inverse Laplace transform. Inverse Laplace transform to the output of the system. Here output or response of the system in S domain is C of S, and it is given by the product of the transfer function. Transfer function is here M of S and the input is R of S. Now I am going to consider the inverse Laplace. Here see, observe the output or response of the system in S domain is C of S equals to R of S into M of S, and the inverse output or else output or response of the any time or else any system in a time domain is the C of t equals to inverse Laplace of input R of S into the transfer function M of S. Here simply the inverse Laplace of C of S is nothing but the C of t, that is the time response, and inverse Laplace of input into the product here or a product of the input signal to the and transfer function of the system. Just we get the time domain output, that is nothing but the response of the system in time domain, right? Where M of S is, we are going to just we consider the where M of S equals to G of S divided by 1 plus G of S into H of S from this circuit diagram, right? And this is the time response. Next coming to the just simply for every time response we have a two responses are available in time response. One is the time response transient response and second one is the steady state response. Just if the output of the control system for an input varies with respect to the time, input is varies with respect to the time, then we call it as the time response. Simply the another definition is, if the output of any control system, output of any control system for an input is vary with respect to the time, then the time that the system is known as, or else the system output is known as the time response of the control system. The time response consists of two parts. One is the transient response and the second one is the steady state response. Simply. Next here, see, observe the response of the control system in time domain. The response of the any control system in time domain is just this one is, just observe from 0 to t. T is the varying the system time is 0 to t, 1 2 3 so on like that. Okay, here the output is C of t, the system response is the C of t, input is 0 to t, 0 1 2 3 4 on like that values are we are going to consider here. Transient response and steady state response, these two are the parts are inbuilt in the single response of the control system. Here transient response and steady state response, this is the graphical representation here. Next here, both the transient and steady state, here observe transient and steady states are indicated in this figure. In this diagram we are observe the transient state as well as the steady state. Okay, the responses corresponding these two, the responses corresponding these two states are known as the transient state and steady state responses. Okay, the mathematical representation of this system response C of t is nothing but the transient response plus steady state response. Here see, C of t equals to transient response plus steady state response, where t or C of tr, C of tr is nothing but the transient response, transient response, where C SS is nothing but the steady state response, steady state responses. Okay, and next here coming to the transient response. Transient response here, after applying the input to the any control system, output takes the certain time to reach the steady state. Here see, observe, an input is applied, input is applied to the certain steady state, up to steady state certain area it will be going to be incremented. Here see, our input to the control system, output takes to certain time to reach the steady state, reach the steady state. So the output will be transient state till it goes to the steady state. So therefore, the response of the control system during the transient state is known as the transient response. So simply here, when we are going to apply the input from here to input is applied to up to reach, it will take the some time to reach the steady state. It will take the some time, that is known as the transient state. In this condition is the transient state, and here that is the transient response also. Here the transient response will be 0 for the large values of t. For the large value of t, the t is infinity, and for ideally it is the t is infinity, or else practically it is the constant value simply. Okay, ideally is the t is nothing but here transient response is infinity, or practically it is 5 times constant. Here simply here a mathematical representation I am going to write here. Mathematically it can write limit t tends to infinity, transient response of t equals to 0. If the value is 0 for the large values, so we are going to just consider the infinity. T tends to infinity, ideally the 0, the transient response will be going to be 0. So transient response limit t tends to infinity is the 0 value. Okay, and next here steady state response. Previous transient response, and next coming to the steady state response. In steady state response, the part of the time response, here see observe the part of the this one, the part of the time response, the part of the time response that remains even after the transient response has 0 value for the large values of t is known as the steady state response. This means the transient response will be 0 even during the steady state. Here steady state, here up to here this value is going to be is the infinity, so completely it has the constant value. So constant value from here to just observe, from we are going to reach the here up to steady state. After that steady state, here completely the value is going to be constant value to directly here the constant value. So steady state, it is the steady state response. Here observe the part of the time response that remains even after the transient response has 0 value. 0 value for the large values of t is known as the steady state response. This means the transient response will be 0. The transient response will be 0 even during the steady state also. Okay, example, let us find the transient and steady state terms of the given time response. I am going to write some here, just here observe. I consider one example. The response, the system response e of t equals to 10 plus 5 into e power of minus t. From this equation, just we are going to identify the transient term is transient term as well as steady state term. Just here observe. 5 into e power of minus t. This is the exponential right here. Transient term, that one is nothing but the transient term, and it is the constant value, or it is the remains. And after the 10 remains even, it approaches to the infinity value. So here, so this steady state term, this one is 5 into e power of minus t will be 0. It t denotes the infinity, and remaining term 10 is nothing but the steady state term. Okay, steady state term, or a steady state. This is the transient term and a steady state term from the given example. Just we observe here. 10 is the constant, and e power of minus t, 5 into e power of minus t is the steady state exponential. Okay, na constant, and it means that is nothing but constant steady state term, that one steady state and transient response. Okay, next here these are the transient response, steady state response, and time response. Time response simply the output of any control system for any input is varies from with respect to the t, then we call it as the time response simply of that system. Okay, time response always has the two parts. Okay, transient and steady state. This is about the transient response, just simply introduction of the transient or time response analysis. In that, what is the how many parts are available in time response, transient response, as well as steady state response, and how to calculate the time response from the S domain system output. Just we are going to apply the inverse Laplace. All these are we learned from today lecture. Thank you.